How's it going, guys? Today we're going to go over another Leap Code question. Tara questions from Facebook, and it's called Add Strings. Alright guys, so Tara problems from Facebook, it's called Add Strings, and our problem description says, given two non-negative integers num1 and num2, represented as a string, return the sum of num1 and num2. So we've actually done a very similar problem like this on my channel previously. We did a problem called Add Binary, and this is the exact same idea. We can solve it basically the exact same way, but the only difference here is that we're actually going to be doing normal addition. We're not going to be adding binary numbers, but just normal numbers. So we're given two strings that are represented as numbers here, and we're asked to just return their sum. And so before we get into this, we have a couple notes. It says the length of both num1 and num2 is less than 5,100 exactly. No idea why it's 5,100. It says both num1 and num2 contain only digits 0 to 9, so that would be a really good question to ask your interviewer. You know, are you guaranteed to have valid inputs in both of your numbers? And it sounds like we actually are here. Number 3 says both num1 and 2 do not contain any leading zeros. And number 4 is you must not use any built-in big integer library or convert the inputs to integers directly, right? Because if we did that, that basically makes the entire problem obsolete. So how do we do this? So a problem like this I like because it's very easy to think about in real life, right? All we actually need to do is think about the process of addition and how we add two numbers in the real world and basically try and replicate that process in code. So when we think about adding two numbers together, what do we first think of? I first think of we start at the back of the numbers, right? We're going to start at the ones place, calculate whatever digits to be put in that place in the result, think about whether or not we have a carry, and then move on to the next digits place, which would be the tens, right? And then the hundreds and thousands and so on and so forth. So all we need to do is replicate that process. So the first thing we should probably do is just declare or initialize a return value. And here we want to return the string representation of their sum. So I'm going to create a string builder called result. So let's do that. So string builder result equals new string builder. And now let's just have two pointers to actually start at the ends of each of the respective numbers so that we can try and make sure we're always adding the correct digits together before we place whatever their result is into our result. So let's say integer I equals num1.length minus 1 and int j equals num2.length minus 1. And again, this is solely because of the fact that in addition we start from the back of the number and slowly move forward. Great, so now the other thing that we talked about was a carry, right? Anytime we add two of the columns together, we could potentially have a carry. A carry is going to be any time that we have a number or a resulting sum between two columns that are greater than or equal to 10. And initially our carry is going to start as 0, right? We haven't added anything together, so our carry would start at 0. And now we just want to continue the process while we haven't gone through the entirety of each of the respective numbers. So now we need a while loop to continue while I is greater than or equal to 0 or j is greater than or equal to 0, because that definitely means that we have a number to process. So we could say while I is greater than or equal to 0 or j is greater than or equal to 0, we actually have to calculate a number to put into our result, right? Or a digit to put into our result. So now let's actually get the sum of the two columns that we need to look at. And that's going to be basically the index of I in num1 and the index of j in num2, trying and add those two things together. So our sum initially is just going to be equal to our carry, right? So any time that we did a previous computation, we need to make sure that if we have a carry, we consider it in this current computation that we're about to do. And now we need to think about the edge case where what if one number is longer in length, right? Has more digits than another number. So before we actually just go and add the ith digit to sum or the jth digit to sum, we need to make sure that we actually have one of them. So a quick check for I and j will do that. So we'll say if I is greater than or equal to 0, then we definitively have a digit to process. So we could add that digit to our sum. So we'll say sum plus equals num1.char at I, and I'll say minus minus, so that next iteration we don't evaluate the same digit. And then here we're just going to subtract the 0 character. And so what this is basically going to do is it's going to get whatever character is at the ith position, let's say it's 5, by subtracting the 0 character from the 5 character. That's actually going to convert the values into ASCII. And it actually turns out that 5 as a character is 5 spots away in ASCII from the 0th character. So we'll actually just go ahead and convert the character into an integer for us, which is super nice, and that will actually correctly add its value to our sum. So now we're just going to do the exact same thing for j. So if j is greater than or equal to 0, we need to add the jth digit in num2 to our sum. So we'll say sum plus equals num2.char add j minus minus, and same thing, minus the 0th character. Great, so now by the time we get to line 16, all we need to do, right, is actually take whatever that sum is and use its result to put into our result string builder, right? So whatever their sum was, let's say it's 12, we would in this case need to put 2 in that digit spot and have a carry of 1 for our next iteration or our next computation that we're going to do. So we know that the digit we're going to place into our result always has to be between 0 and 9 inclusive. So we could actually say result dot append whatever our sum is mod 10. So like if our result or our sum here was 12, if we did 12 mod 10, we'd be placing a 2 into our result. And now for our carry, we said our carry is only going to be interesting if the resulting sum was greater than or equal to 10. So we want to set our carry equal to our sum divided by 10. Great, and so now by the time this entire loop on line 7 terminates, we actually have our result minus one little thing, and that is the case where our most significant digit slot was resulted in a carry, right? So adding two numbers together, the most significant digit slots in each of num1 and num2 resulted in a carry. We need to not forget to add it to our result. So we could simply check if carry is not equal to 0, let's just say result dot append whatever that carry is. Great, and so now on line 24, all we actually have to do now is return our result, but the one caveat is just the fact that we actually appended everything to our result, which is basically putting it at the back, right? And we started at the back of our numbers, so our answer is effectively reversed, right? So we just need to return our result reversed dot toString. Great, so now before we submit this answer, let's just talk about our runtime. So our runtime, well, here we're just going through all of num1 and all of num2, right? So we could say that's O of n plus m, where n is the length of num1 and m is the length of num2. You'll notice that I'm actually using two different variables because they could be varying lengths. So we'll say the runtime is O of n plus m, and then in terms of our space complexity, all we're doing is creating a string builder, right? And our string builder could be at most basically the size of whatever n or m is, whichever one is bigger, plus 1 in case we have that carry, right? At most we'll have one additional character to consider the case where like a 2-digit number becomes a 3-digit number when you add something to it. So again, our runtime is going to be O of n plus m, and we could say the space complexity is the maximum between n and m. So O of n or O of m, whichever one is maximum. So now let's run this. Let's make sure that it works. Awesome, and it does. So guys, that's how to solve add strings in Java. Again, it's a question that's being asked by Facebook right now. If you guys enjoyed this video and found it helpful, do me a favor and leave the video a like and subscribe to the channel for more. And I'll see you guys next time.
Perfect.